understand. A voltmeter connected across the terminals of a cell reads 1.5. When the cell supplies a current of that to the voltmeter reach 1.2. What is the internal resistance of the cell? Now, please, when you do this test, please remember that V equals IR is your most valuable equation. But you can only use it if the V's and the I's and the R's are for the same thing. So if they say calculate the internal resistance of the cell, you can use V equals IR if that is the little r. With me? And you must just make sure that this V is in the internal V. So if this is internal, then this is internal, and this is internal. They must just all be the same. You could always use V as IR, as long as it's for the same thing. Ohm's law works. That's Ohm's law. Voltage and current is directly proportional to. Okay, you can always use it, but only if it's for the same things. So you can't use internal and internal voltage and external resistance. That's not going to work. So now we need to think, what is the internal voltage? When there was no current, okay, it reads 1.5. Then when there is a current, it reads 1.2. What happened to that extra voltage? Went to the cell. That is V internal. So to get V internal, you're just going to say that's going to be 1,5 minus 1,2, and that's going to give me 0,3 volts. And that is my V internal. So V lost, we don't really use the word V lost, the term V lost anymore. But if you want to use it, it's okay. It's not really lost, it's what the battery uses. Okay, so that's lost inside the battery because it's not available for external. So these two are the same things. So that is going to be 0,3. Internal current, external current. If electrons move inside, they must move outside. Remember, they are actual particles that move around in the circuit. So that means if the current outside is 0.6, the current inside is going to be 0.6 as well. And that gives us an R. So you don't have to go and use any complicated equation. You're just going to use that. And you're then going to say, R, please don't do the maths in your head like I do, and I always get the wrong answer. It's 0, I would say that's 2. See, there it's wrong already. 0,3 over 0,6. And that is 0.5. And what's the unit? Okay, if you get 50 for an internal resistance, you must know that you're wrong. Okay, internal resistance is pretty small normally. It's not always 1, but it's small. 0 point something. I don't know. There's no rule, but it's normally small. Okay, do you understand the whole thing about V, IR? I can use it for inside, I can use it for outside, I can use it for one resistor, I can use it for all the resistors in parallel. As long as the V's and the I's and the R's are for the same thing, you can always use it. If it's not for the same thing, you can't use it. So please be careful. Okay, so let's look at the second one. Still internal has some internal resistance there. So it says 2 circuits. The EMF here is 9, no internal resistance. And here the internal resistance is 0.5. When both switches are open, what is the reading on the voltmeter in circuit 1? So when these two switches are both open, what would the voltmeter reading be? 9, because you always look, where is it? It's still connected. If it goes this way, there's a gap. So it's measuring nothing there. But when you connect it like this, it's still connected across the cell. So that means it's still going to give you 9 volts. These switches are also open. Is there any current flowing? No. So if there is no current flowing, what does this give you? The maximum energy that the cell can provide per coulomb of charge. That is the definition for EMF. Yeah, but you don't have to say positive. Yeah, so I've spoiled you, I've realized. Because I know I must make flashcards all the time.
No, but the thing is, when you learn from the science, you think maybe like I'm missing something. So then we know everything that. And that's why it's complicated also. When you find circuits in chemistry,
Yeah, know that define. It's not just define it as something.
But I put those on the flashcards as well. They must be there. You must learn them. All right. So that's going to be 9 volts, and that's going to be 9 volts if all the switches are open. Because there's no current flowing, so it's kind of the same thing. So please remember that if there is no internal resistance, voltage inside or voltage across the terminals and voltage across the circuit is going to be the same because the battery gets nothing. So it wouldn't have dropped like it did there in that first question that we did. Okay, then now we are opening the switches. So they say when switch 1 is closed. So on your use your pencil and close it so that you can see what's happening. So only switch 1 is closed. What is the reading on voltmeter in circuit 1? So now there is a current flowing. So is this voltmeter reading still going to give you 9 for this one? Is the battery stealing anything if they tell us that there's no internal resistance? The battery's stealing nothing, so it will still be 9 volts. But in this circuit, the battery is stealing something. So they didn't ask us for that. They say, what is the reading on the voltmeter in circuit 1? Circuit 1 will still be 9. Then they say, what is the total resistance in circuit 2? So in circuit 2, let's see what is there. So now that switch is closed. So this is our circuit that we have. The other switch is still open. So we have just that series circuit. So there's the 4 ohms and the 0.5 ohms. So what is the total resistance in this circuit? The 0.5. Oh, sorry, 4.5. So it's 4.5 ohms in that circuit. So this is the total resistance. So total resistance is inside and outside together. So it's the 4 plus the 0.5. That's the total. If they say total external, then it would just be the 4. If they say total internal, then it would just be the 0.5. But now it's the total resistance. Then they want to know what is the ammeter reading on the circuit. What is the equation you can always use? V equals I plus R, but you need to make sure that it's for the same thing. So if I use this, if I use the only voltage that I have at the moment, which is the 9, that is the total voltage. So if I use the total voltage, which is the 9, then I need to use the total current, or I'm going to calculate the total current. But then what R must I use, the 4 or the 4.5? The 4.5, because I'm working with totals. So V total is I total plus R total. As long as they're all the same, happy days. So this is going to be R total, which is our 4.5. So they try to lead you a little bit here. So that gives us I is 9 divided by 4.5, and that is 2 amperes, which is realistic for a current. When you're working out something, put it in your circuit so that you have it for future use. We see often that people go and recalculate some things. Now they want the voltmeter reading. Is the voltmeter reading still going to be 9? Why not?
there's a current flowing through the light, so there's going to be internal resistance.
So the battery's going to eat some of that energy. So I can work out how much energy the battery is using by again using V equals I little r. Because then this will be V internal. So this is what the battery's stealing from the 9. So then I've already got the current. Current inside is the same as current outside. So that's 2. The little r we know is 0.5. So that gives me that internally, the voltage that the battery steals is, what's 2 times 0.5, guys? 1 volt. So if that is 1 volt, so if the battery is stealing 1 of the 9, what is left over for outside? 9 minus the 1, which is just 8 volts. Can you see the logic in it? Work it out logically. Don't go and try and use these fancy equations if you don't know why you're using them, because that's when you use the wrong values in the wrong places. Why does the voltmeter in circuit 2 not read the same as the voltmeter in circuit 1? Okay, so this is an explanation type question. So in circuit 1, there's no internal resistance. You've got the answer, so I'm not going to write it out properly. Therefore, no V internal. And therefore, V external is going to be equal to the EMF. But in circuit number 2, there is a little r. So there is a V internal. So that means that V external is going to be EMF minus V internal. Because the battery steals some of the energy and the rest is available for outside. Electricity is awesome because you just build puzzles. You go from one place to the next, to the next, to the next. I like it. Now both switches are closed. So can I use any of the information? What information stays the same?
The voltage.
Current doesn't stay the same. Voltage doesn't stay the same. Were you closing this other switch now? So the resistance changes, the current changes, the voltage changes. There's only two things that always stays the same. Internal resistance and EMF. Please remember that. So EMF and internal resistance stays the same. And this is where they always ask you that question, what happens to the voltmeter reading? Okay, so they're probably going to ask us. Okay, so they both close. What is the reading on the voltmeter in circuit 1? Okay, so that voltmeter reading is still going to be 9Y. This voltmeter reading, because it's still the EMF. And it's connected across both of these, and they are in parallel. So the voltmeter across this one is the same as this one, is the same as the EMF. All those voltages are exactly the same. Now they want the total resistance in circuit 2 again. I actually want to move these diagrams, just so that I can move it up quickly. Sorry. Come on. My fingers are cold. It's not even picking up that I'm touching it.
I think you might be able to speak.
Okay, so circuit, where are we?
20.2 now.
Okay, so both switches are closed here. Sorry, I went back there. Okay, both switches are closed. So we said 9 volts. And what is the total resistance in circuit 2 now? We've got a 4 and a 4 and a 0.5. If it's a 4 and a 4, what always happens when you connect things that are the same in parallel? Becomes half of what it is. Yeah, so this will be 2 plus 0.5, so it will be 2,5. If you want to write it out properly, if you have to show your working, you're going to say R total is equal to the 0.5 that is in series, which is the internal, plus, and then just do the maths in one step. 1 over 4 plus 1 over 4 to the power of minus 1, and you type it in your calculator and you'll still get 2.5 ohms. Happy? What is the reading on the ammeter in circuit 2? It's not going to be the same anymore, but you can still use V equals I times R, because you can still say V total equals I total equals times by R total, but make sure that they are all the same. So we can still use the 9 if we go and we say it's I times by the 2,5 now. And then I becomes, tell me, calculators. You can't be here without a calculator, remember? Come. 2, 3,6 ampere. Just quickly tell me, if we wanted to know about this current, would the current be the same, smaller, double, not double, less than double? It will be higher as well. So remember this one was 2 ampere originally. So in this one, it would be a little bit more than 2 ampere because it doesn't have internal resistance.
It's not before now.
It would be double, yeah, we exactly double. But in this one, it's not exactly double because remember that the battery is eating some of the energy or stopping some of the current from flowing. All right, so it's not 2 anymore. Okay, so now we know it's 3,6 ampere. So again, already we know that the current went up. Why does, when I put something in parallel, does it make the current higher? The resistance decreasing, you're opening more doors. It's easier for the electrons to move because there's more paths for them to follow. Okay, what is the reading on the voltmeter? That was the ammeter, the voltmeter in circuit 2. So now when they say the voltmeter, it's always external. No voltmeter can measure internal. You always have to minus to get internal. So voltage in that one is then there's a few ways to do it. You can say that, okay, give me a way. You can say V.
V total is V. The V external is V total minus V internal.
You can do that. Okay. Guys, remember in electricity, that's also a nice thing about electricity. There's many ways. You can say V external, which is what they're asking us for. The reading on the voltmeter is V external, is going to be the EMF minus V internal, minus what the battery is stealing. So it's going to be 9 minus V internal. Now, we already worked that. Oh, no, we haven't. So V internal is equal to I times little r. We know that I is 3,6 and we know that little r is 0,5. So the V internal is
Internal is
V internal is 1,8.
1,8. So this is going to be 1,8 and then this is going to be 7,2 volts. So that's the one way of doing it. Otherwise, you could still say V equals IR if you use V external, I external, R external. It's all be the same. So then, what is V external? Well, that's what we want. Sorry, that's what we want. Do we have the current? Yes, we know that is 3,6. Do we know what the external resistance is? So that means we get 7,2 volts. There's even another way. You could have said this 3.6 splits up here and here. Because they are equal, what is each of them going to get? Half of 3,6, which is 1,8, 1,8 ampere. You could have said that. Then you can say this Vx and is connected over each of these things. So you can say that the voltmeter reading there is equal to I times R of the 4 ohm resistor. If it's the current of the 4 ohm resistor and it's the resistance of the 4 ohm resistor. As long as they're all the same, happy days. So that means that is going to be equal to, the current we said is 1,8 and the resistance is 4. Do you still get 7,2?
Yes.
How lovely. See how many ways there's in electricity. Sorry, just. Okay, so any of those 3 methods you could have used. Then they say for circuit 2, explain why the voltmeter reading decreases when the current increases. That is the question. That's the question that you asked about. They ask this all the time. They say, what happened to the voltmeter reading? Use equations. Okay, so please remember that if you get a question on Wednesday, which you're probably going to get like this, then you need to use the equations. So, what are you going to say? Why does this voltmeter reading decrease? Which one?
V is equal to I small r.
Please don't ever use that equation in any explanation because it means 0. Is there a V in that equation? Doesn't help you. So please don't. So when you get a question like this, explain what happens to the voltmeter. Always think, what have you changed? Okay, you have changed the current. You close the switch. How did you change the current? So always ask yourself, what happens to the current? This is I total. What happens to the current when you add more doors for these things to run out of? The resistance decreases, so the total resistance decreases, so the total current is going to increase. So you always do that first. Step one. What happens to the total resistance? Therefore, what happens to the current? Then you go and say, okay, I need to think the voltmeter reading would be the same as the EMF if there was no internal resistance. So the only reason why it's not the same as the EMF is because of the internal resistance. So our next step is to see, okay, what happens to V internal? So they're calling it, in that the old notes, they're calling it V lost, but rather call it V internal. So V internal or V lost is I times little r. But what do you know about little r? It's the internal resistance and it's constant. Please, if you don't mention the constants, you will lose a mark. Constant. It's constant. So if little r is constant, but I goes up, what's going to happen to V internal? It's going to go up. Now you go and look. You know that EMF is the total voltage, the total energy supplied to each coulomb of charge by the cell. Okay, so that's the definition of EMF. So EMF is V internal plus V external. That is on your information sheet. I think they call it V load for external. Doesn't matter. But you now know, what again do you know about EMF? Constant. If the EMF must remain constant, but the battery is now stealing more energy, is there still the same amount available for V external? No, so V external is going to go down. So therefore, V external decreases. Please remember that they do not allow the up and down arrows anymore. So you actually have to use the words. You can't just say up and down arrows. Does this make sense? So don't just learn it.